So in the previous class, we discussed about how the thread task scheduling or preemptive task scheduling techniques. How means how processes are going to be executed by a system. So all processes are kept in a queue. Okay, that is known as a ready queue. So one by one, the processes are going to be executed by referring that queue contents based on some different techniques. Let us move towards how the communication is going to happen between tasks. Okay, because here we are working in the embedded system where the processes or tasks are working concurrently. So in a multitasking system, because we need a multiprocessor, so it is going to perform so many tasks at a time. So in a multitasking system, multiple tasks or processes run concurrently, and each process may or may not interact between. So it is not mandatory that they are going to communicate each other. Okay, but some of the major applications or processes or a task, they are when they are working concurrently, they are going to interact each other. The processes share some area of memory to communicate among them. So how the communication is going to happen, it is based on the memory which is shared between them. The implementation of shared memory concept is purely kernel based, because kernel is the main heart of the system. Okay, so kernel is going to give the all these tasks, that is task communication, task synchronization, scheduling, as well as the communication between all the tasks. It is depend upon the kernel behavior. So here one of the method what we are going to use in the shared memory, it is pipes. So pipe is a section of shared memory used by processes for communication. So it is nothing but a separate area, a memory area. It is allocated for shared memory between two or more than two processes. So how they are going to communicate each other? So it is based on the memory allocated to them. So one of the method is pipes. So pipe is a section of shared memory used by processes for their communication. So a process which creates a pipe is known as, that particular process is known as pipe server, and that process which it wants to communicate, okay, that another process is going to known as pipe client. So here if two processes are communicating each other, so one which is created that pipe, which is created the signal, request signal, so that process is known as pipe server, and to which it is generated, to which as one process to which it want to communicate, so that another process is known as pipe client. So it is a unidirectional pipe, allows the process connecting at one end of the pipe to write to the pipe, and process connected at the other end of the pipe to read the data. Means what? It is it may be unidirectional or bidirectional, depend upon the task. Okay, when two processes are communicating each other, interacting each other, then depend upon the requirement, it may be used as a unidirectional or bidirectional. So what is this unidirectional? So here at one end of pipe, the pipe server is going to send the data, and another side of this pipe, that is where we are going to observe the pipe client, means another processor is available at another end of the pipe. That one is going to read the data. Okay, but what about this bidirectional? So here pipe server, nothing but the first processor is going to communicate, meanwhile it is going to send the data, meanwhile the pipe client also, it is going to receive as well as write the data. So here the ends of this pipe So one end server is there, another end client is there. So unidirectional, nothing but what? Only server is communicating with client. What about bidirectional? The pipe is used for sending and receiving data at both the ends. At both the ends. So that is pipe concept. So another one comes, it is a memory mapped objects. Memory mapped objects. So what is this memory mapped object? It is a shared memory. Once again, the memory area is shared between two processors. One type of memory sharing is concept is pipes. Another type of concept it is memory mapped object technique adopted by certain real-time operating systems. Real-time operating systems, nothing but what? In this approach, a mapping object, one another object, a recognizing element object is created and physical storage for it once reserved and committed. Means what? In this memory mapped object, this much memory, it is utilized by these two processors. It is kept in the fashion of a virtual memory or an object. So this object is going to, whenever the interaction is going to happen between two processors through that memory, so that memory in utilization, it is done through these objects. So those objects are nothing but what? Memory mapped objects. So all read and write operations to this virtual address space by a process is directed to its committed physical area. So it is a virtual address, what it is going to be created for allocated shared memory. So whenever the process want to communicate, they are going to utilize this object. So any process which wants to share data, so we are going to observe this type of concept in the class and class objects. So what is nothing but what? Here the same variable I, same address, same memory location, it is used by different processors. Nothing but what? One object, multiple, means one memory, it is recognized by one object, a virtual address. Okay. So same concept is adopted in memory mapped objects. So any process which wants to share data with other processes can map the physical memory area of the mapped object to its virtual memory space and use it for sharing the data. So here that particular shared memory, it is recognized by the process ID itself. Process ID. So process 1 dot the respective name of the memory. Similarly, the processor 2, it is going to use same memory with a different label, with a different address. So what is the address of the same memory with respect to process 1? So process 1 is going to use that memory as process 1 dot. What about process 2? It is going to utilize same memory based on another name, that is process 2 dot. Similarly, n number of processes, if same memory it is shared among n number of processes, then what is going to happen? The same memory has a virtual addresses for data transmission. The memory mapped object can be shared between the processes by either passing the handle of the object or by passing its name. As we discussed here, we may pass that one to a respective name. So the process, the same memory is only, as I said, a name is given to all the processes. The name remains same, but identification is on what? The respective processor. Process, that is process 1 dot the respective name, dot name, process 2 dot name, process 3 dot name, like that. Then another technique comes, it is message passing. So message passing is a asynchronous or a synchronous information exchange mechanism used for inter-process or thread communication. So message passing is relatively fast and free from synchronization overheads compared to shared memory. So synchronization has to happen in the shared memories. So based on the message passing operation between the processes, message passing is classified into message queue. Usually a process which wants to talk to another process posts the message to a first in first out queue called message queue. So whenever it is a message passing nothing but what? It is a shared memory where it is in the form of one type, it is message queue, it is in the queue fashion, first in first out, or the mailbox. The mailbox is an alternate form of message queue and it is used in certain RTOS for inter-process communication, and it is going to be used for one way of messaging. Another one is signaling. Signals are used for asynchronous notification, where one process or a thread fires a signal indicating the occurrence of a scenario which other process or a thread is waiting. Means through signals or through mailbox concept or through message queue. The shared memory is going to be utilized between processes. Here, another concept is remote procedure call or RPC. So here we can observe it is between over the internet, over the network, or within the CPU. The processes which are running on the same CPU, they are going to utilize the concept of network using the network protocols. It may be TCP or IP or a UDP over sockets. Okay. So here we are going to observe the diagram illustrating the remote procedure call. Here the processor which are kept in the remote area. It may be within the CPU or between two processors. Okay. So for remote, the processors which are running on different CPUs, they are going to use the network protocols. Within the CPU, they are also going to use the layer protocols. So this RPC is the inter-process communication mechanism used process to call a procedure of another process running on the same CPU or on a different CPU which is interconnected in a network, because these processes are kept in a remote area. It may be within the CPU or it may be on internet. So this RPC is mainly used for distributed applications like client server applications, because if you go for the task communication through this web technology, so in your browser, you just once you click means what? It is a process is go on running in the client CPU, but the actions and reactions are the process which are related to that process which is generated by the client. They are purely related to the server process. So how they are going to communicate? One process in the client side is want to communicate with another process which is kept in the remote area, that is server CPU. So how they are going to interconnect? They are connected through this remote procedure call concept over internet through internet protocols and sockets. So here, what are the sockets? Sockets are used for RPC communication. So socket is a logic endpoint in a two-way communication link between two applications running on a network. So through these sockets, the communication is going to happen between the processors which are kept in remote areas. The CPU or a process containing the procedure which needs to be invoked remotely is known as a server, and the CPU or a process which initiates an remote procedure call is known as client. So these are the things with respect to communication. So the communication is going to happen through remote procedure call or pipes, memory mapped objects, or by message passing. In message passing, we have the techniques like message queue, mailbox, or signaling, then RPC. So these are the few task communication concepts introduced in embedded systems. So in the next class, we deal with how the synchronization is going to happen between processors. Once the communication is established, once the communication between two processors is established, how the synchronization is going to happen. We will talk about that one in the next class.